Last bit in trig rules then is looking at bearings. So it hasn't changed any of the trig rules, but sometimes we do need to do a wee bit of work to find the angle that we need to use before we can do our calculation. Okay, so a bearing is an angle that's always measured clockwise from north, and it's always written using 3 numbers. So instead of writing 30 degrees, a bearing would be written as 0, 30 degrees. So if we look at this first diagram they've got here, we say the bearing from A to B is 78 degrees, because that's the angle clockwise from north that I would need to go if I wanted to walk from A to B. The bearing from B to A is the other way, so it's the angle I would need to walk on clockwise from north to go from B to A. So it's all the way around this part here, and that's where it can be quite tricky to work out the size of the angle. So if we extend this line down here, extend this line down here, we've got alternate angles here and here, or Z angles if you prefer. So that is also 78 degrees. Here's a straight line, that's 180 degrees. Add them together and we get a bearing of 258 degrees. So sometimes we need to do a calculation like that before we can use our sine rule or cosine rule. Let's have a look at some examples then. First one, there are 3 moorings, point A, B and C on Lake Soling. So there's A, there's B, there's C. From A, the bearing is 74 degrees. From C, the bearing of B is 310 degrees. That means all the way around there is 310 degrees. And we want to calculate the size of angle ABC, which is this angle here. Okay, let's see if we can figure this out then. So, if I make this into a triangle. Right, if we think about this line here, straight line there would be 180. All the way around to our line here is 310, which means this wee bit in here must be 50 degrees because a complete turn would be at 180. Okay, if we put an extra north line in then, if I put an extra north line in here, it splits up this angle here. So see, I've got an alternate angle here. That means that one there would be 74 degrees, and we've also got this alternate angle here. So this one would be 50 degrees. So to get my angle ABC, I'm going to do my 74 add 50, which is 124 degrees. Change away from this red pen. Okay. B is 230 metres from A, so there's 230 metres. And B is 110 metres from C, so that's 110 metres. Calculate the direct distance A to C. Right, my diagram's got a bit messy here, so I'm just going to draw out my triangle again. So I know that this distance here, I think I've put that 230 in the wrong place, haven't I? I have, it shouldn't be there. 230 is what? B is to this one here, B from A, 230 metres. Right, so that there's 230 metres. That's my A, that's my B, that is 124 degrees. We're only looking for things inside the triangle, length, so that's 110 metres, and I want to find the length of this one here. Okay, so I've got 2 sides in the included angle, so I'm going to use the cosine rule. So cosine rules, A squared equals B squared plus C squared minus 2BC cos A. We need this pairing again, that we know the angle opposite the one we're trying to find, which we do, perfect. So x squared is 230 squared plus 110 squared minus 2 times 230 times 110 times cos 124. I don't think I've given myself enough room to do one of these questions yet. So x squared is, let's get the calculator working, 230 squared plus 110 squared minus 2 times 230 times 110 cos 124. That's 93,295.16, 93,295.16, is that right? 93,295.16, yep, that gives me x squared. So to find x, I need to take the square root. Lost my calculator there. Square root, and the answer gives me 305.4. Let's see if we can put them here. So x is 305.44 meters. I want an answer to 3 significant figures. So there's 1, 2, 3. It's a 4 after the decimal point, so it doesn't round up, it stays as 5. So 305 meters. Go away. Oh, come on. Right, sorry about that. There we go. Right, let's try the next one. Number 2. In a race, boats sail round 3 buoys represented by A, B and C in the diagram below. B is 8 kilometres from A on a bearing of 60 degrees. That's already drawn in. Brilliant. C is 11 kilometres and A is 13 kilometres from C. Calculate the size of angle ABC. So that's at this angle here. Okay, it's in a triangle. I know all 3 sides of the triangle. I know all 3 lengths, so I can use the cosine rule. Cosine rule for finding an angle is cos A equals B squared plus C squared minus A squared all over 2BC. The only one that needs to be different is A. A must be this one here because it's across from the angle that we're trying to find. Doesn't matter which one's B, which one's C. So 8 squared plus 11 squared minus 13 squared divided by 2 times 8 times 11, which is, picking up my own calculator here, let's get the one on here instead. 8 squared plus 11 squared minus 13 squared all over 2 times 8 times 11 is 1 over 11. That gives me cos A. I want to find A, the inverse cos of an 11th. So A is 84.8 degrees. So that is angle ABC. Part B then says, hence find the bearing of C from B. It's the bit here that's been marked in for us. Okay, so we've just worked out that this angle here at B is 84.8 degrees. So that there is 84.8 degrees. I want to find this part here. Okay, what I'm going to start by doing is extending down my north line, but I'm going to get rid of some of these other things that I've got written in here because it's getting a bit messy. Come on over, there we go. Tidy it all up. There we go, right. Let's extend this north line down then. I know that this angle here is 84.8. My aim is to find this angle here. I also know that 60 there and this part here must be the same because here we've got an alternate angle. It's a Z angle between the 2 north lines. North lines are always parallel. Let's make these Z shapes. So that is 60 degrees. If that is 60 degrees, this side of it must be 24.8 degrees. If that's 24.8, that full part round to the line will be 180 because it's a straight line. If that's 24.8, to find that bearing, we do 180 take away 24.8, which is 155.2 degrees. Because we want it as a bearing, we're going to have it as 155 degrees. They are both supposed to be 5s. They don't look much like it. Keep getting a wee drag from this graphics tablet. 155 degrees. There we go. Now, these are the trickier of the questions, the bearings questions. So remember, please, and get in touch if you have any trouble with them. Sometimes it can be hard just to get started spotting the angles. So I can spend time going over some of these if you need me to. Okay, speak to you soon.